Hi everyone. Today, I'm going to demonstrate the pgDuckDB extension on Azure Database for PostgreSQL. Before we start the demo, let me give you a quick overview of what pgDuckDB is. pgDuckDB is a PostgreSQL extension that embeds the DuckDB engine inside PostgreSQL. DuckDB is an in-process analytical database optimized for vectorized execution, making it extremely fast for analytical queries on large datasets. With pgDuckDB, you can run high-performance analytical queries directly inside PostgreSQL, access external data formats like Parquet and CSV without loading them into PostgreSQL tables, benefit from DuckDB's columnar processing while staying in the PostgreSQL ecosystem. This is especially useful for scenarios where you need fast analytics on large datasets without complex ETL steps. I'll show you two use cases today. The first one is querying Parquet files stored in Azure Blob Storage directly from PostgreSQL. I'll start by creating a flexible server. I will name the server as pgDuckDB Demo. I'll choose PostgreSQL version 17, set the username and password, and create the server. To install pgDuckDB, go to Server Parameters in the Azure portal. Add pgDuckDB to the Azure.Extensions parameter. Also include and shared preload libraries. Save the changes and restart the server. Once the server restarts, let's connect to the server using PSQL and try creating the extension. Now pgDuckDB is installed and ready to go. I have an Azure storage account with a container ready. I'll upload a Parquet file containing stock market data. Next, I'll generate a SAS URL for the file so PostgreSQL can access it securely. Using pgDuckDB's read Parquet function, we can query the file directly. And here's the result: data read directly from the Parquet file in Azure Blob Storage without importing it into PostgreSQL tables. That's powerful. Now, let's move on to the second use case, where we showcase how pgDuckDB can deliver a substantial boost in query performance by leveraging DuckDB's powerful execution engine. For this demo, I'll use the tpchq1 query. To prepare, I've created the line item table and loaded approximately 774 megabytes of data. Next, I'll run the tpchq1 query and compare execution times between PostgreSQL's native engine and DuckDB's vectorized execution. First, let's execute the query using PostgreSQL's default engine. Currently, the parameter DuckDB.force execution is set to off, meaning the query will run on PostgreSQL. Executing now. The query completed in over 6 seconds. Now, I'll enable DuckDB execution by setting DuckDB.force execution to on. This routes the query to DuckDB's engine. Running the same query again. This time, it finished in around 2 seconds, nearly 3 times faster. This clearly demonstrates the power of pgDuckDB for analytical workloads. DuckDB's columnar engine excels at high-performance scans, aggregations, and joins over large tables, making it ideal for analytical queries. The pgDuckDB extension, now available in preview for Azure Database for PostgreSQL, combines PostgreSQL's transactional reliability with DuckDB's analytical speed for large datasets. Together, pgDuckDB and PostgreSQL form an ideal solution for hybrid OLTP plus OLAP environments, enabling you to run analytical queries directly within PostgreSQL, without sacrificing performance.